Okay, in the interest of time, I'm going to go ahead and get us started. So welcome everyone to part 4 of the NHERI GSC Research Tools Workshop series. I'm particularly excited about this talk as it's very pertinent to my research, but I'm very excited about all of the talks that we've had so far. This is our second to last in the series, and so we'll invite you at the end to join us for our final in this workshop next month. This workshop has been a joint effort between myself and my vice chair of research, as well as the NHERI GSC working group about workshops and mentoring, as well as NHERI SimCenter. And so I'd like to welcome all of you today to our talk on simulation of regional hurricane impact using SimCenter tools. The NHERI Graduate Student Council is an initiative that's a bit over a year old at this point. It's been a very exciting initiative for myself and all of those who have been a part of it. We've been excited to build a diverse graduate community for natural hazards researchers, connect with mentors in the community, and hear from some brilliant facilitators in these types of workshops, attend these workshops, encourage DEI conversations, learn about the impact of research on practice in natural hazards, and finally gain valuable leadership, service, and funding opportunities. For those of you who are maybe not part of the NHERI GSC yet, I want to strongly encourage you to get involved and join. As I said, it has been a valuable opportunity for those of us who have already been a part of it. We have a number of exciting initiatives, a few of which we'll talk about at the very end. For those of you who may not be members, this is the QR code to join, and we'll repost it at the very end. And even for those of you who maybe are not graduate students, but would still like to become involved, there are tons of ways, whether it be giving a talk at a meeting, facilitating a workshop like this, or anything else. And so if you'd like to support and get involved, please let us know. With that, I'd like to introduce our speaker for today's workshop in the Research Tools series. I'm so excited for this talk. Dr. Steven Gavrilovic is a digital risk and resilience engineer at ARUP and part of the risk and resilience team in San Francisco. His main research is on IRIS, a digital platform for risk and resilience analysis. In addition, he is the lead developer of HAPI, a multi-hazard API for quantifying natural hazards across the globe. Dr. Gavrilovic is also a part-time software developer and postdoc at the NHERI SimCenter at the University of California, Berkeley. At the SimCenter, he's the lead developer of the Regional Resilience Determination Tool, also known as R2D, which is employed to simulate the performance of urban regions subjected to different natural hazards. As you can see, he's very well qualified to give today's workshop on R2D. He was also involved in the development of OpenSRA, a seismic risk assessment tool for natural gas infrastructure, and he received his PhD and Masters of Applied Science in Civil Engineering from the University of British Columbia, specializing in structural and earthquake engineering. Really quick, I would just like to ask that all questions be held until the end, just to give our speaker plenty of time to demonstrate everything he'd like to show. And I'd also like to remind everyone that this session is being recorded for future reference, as well as to share this with others who are not able to join us today. Stephen, I'd like to now turn it over to you.
Thank you very much. Let me share my screen here. Hopefully you can see it now, and you can see the slides. And can you see it? Everything good?
Yes.
We're good? Okay. I just jumped the slide. Perfect. Good morning, everyone, and welcome to this workshop. My name is Steven Gavrilovic. I won't talk too much about myself. Tay did a great job introducing me. Thank you. Basically, I work at ARUP now. I've been at this SimCenter for the last 2.5 years, and maybe the last 6 months, I think I've transitioned over to the R&R team at ARUP in San Francisco. I'm excited to show what RTD has to offer today, and hopefully it can help your research. So I won't spend too much time here because it is recorded. You can always come back to this, but I will steal that QR code idea with the slide instead of these links. I think it's a much better solution. But anyways, you can always go back to this page in the recording, and you'll see some links here for the tool webpage, documentation, a QGIS documentation. You'll see why that's important in a few minutes here. In the GitHub page, RTD is completely open source. So both the front end and the back end, all the code is sitting there. And then there's lots of instructional videos on the SimCenter website where you can go and watch some, what are the workshops I've given in the past and training videos, that sort of thing. So here's a quick overview of RTD to give some background. Essentially a combined geospatial processing tool for multi-assets, in this case, buildings, lifelines, and I mentioned the natural gas pipelines. We're also doing water pipelines now. And then multi-hazards, so we support earthquakes, hurricanes, and then tsunamis. And we are working, bringing in other modules for lifelines as well. So if that's part of your research, it would be great to work with you and bring things in. So as I mentioned, RTD is open source. It should be extensible, which means you should be able to come in and plug your own code in. Our backend is completely in Python. So it's a very well supported language. And I guess a lot of research is done in Python. And the way it works is we have a front end user interface. So that's what I'm going to show today in a demo. And then the back end is basically code. So the front end will create an input file and that will be fed into the back end. You'll run the processing in the back end. And then the front end will digest that again. And I'll argue why the front end is useful for developing those input files and helping you select the type of assets you want to analyze or to set up your research question. And if you're an expert, you could jump right into the back end. You could create your own JSON input file and change things in Python there and run the back end separately from the front end. So here's where RTD fits into the whole SimCenter framework. I guess I'm not the first presenter from the SimCenter, so I'll skip what the SimCenter is per se, but I'll give a description of the framework and kind of where RTD fits into the whole picture. So whereas some of these other apps like EEUQ, WEUQ, HydroEQ, they focus on single buildings. So you have earthquakes, what are the, say, response of a structure due to earthquakes, due to wind, due to some sort of hydro loading. And then that gets fit into our performance-based engineering application to calculate different decision variables like cost and downtime and so on. And then finally, RTD generalizes all of these apps to a region, whereas these are for a single building, we consider hundreds of thousands of buildings. And that's also important because another important facet of RTD in this regard is you're able to run things on the high performance computer, which we'll get into later, to do these large analyses. But it takes all this other hard work kind of under the umbrella to do that. There's also a few other apps we have which are very helpful. There's Brails, which allows you to construct a building inventory that can be used in RTD, and QuoFem, which is kind of our uncertainty quantification methodology, which is sprinkled throughout each one of these apps. So here's that kind of extensible framework I talked about, and RTD pretty much touches on each one of these puzzle pieces in its workflow. So you'll see there's asset characterization, where we describe our inventory over a region. There's hazard, we describe our hazard, right, in different ways. I'll highlight some of those ways. There's asset and event representation. So how do we link our asset to our hazard? Our hazard could be a raster, or it could be a grid. How do we know what to sample, which point to choose? And then there's response estimation. You could have, say, a finite element model, or you could just take the intensity measure from the hazard and use that to estimate your structural response. And similarly with performance assessment, we can have a OpenSeas or OpenSeas Pi model, or we could just use the intensity measure as their simple EDP into our fragility functions to calculate damage and loss. And finally, recovery, where we want to simulate the recovery of a region following a natural hazard. And here's a quick description of how that graphical user interface looks. This is that main input panel I talked about. So this is QGIS. Essentially, I took the QGIS platform plugin and put it into RTD. So all the power, I should say most of the power within QGIS is available in RTD. So it'll allow you to filter the assets according to different attributes. So you might want to only analyze, let's say, houses with a gable roof, and then compare houses with like a hip roof. I'll show you that in a minute, but there's different ways you could filter these assets, select the ones you want to analyze, and then send them forward for analysis. I'm going to describe this panel selection ribbon next, and this just goes through the different panels. So when I click through these, you'll see how this main input panel will change. And another important part is the program output. So as you're going through RTD and putting in these inputs, you'll want to watch out here. There'll be error messages or status messages telling you kind of what's going on behind the scenes. And there's two ways to run RTD, locally and remotely, and I'll get to that in a minute too. So here's just a quick summary of what this panel selection ribbon means. So each one of these acronyms stands for something else. So we have visualization, that's our GIS kind of main screen. General information, I'll skip over that one. It's kind of describing the analysis in very broad terms like name, description, so on. And then we have our hazard definition, our asset definition, our hazard to asset mapping, our asset modeling, analysis, damage and loss, uncertainty quantification, any random variables that come into our UQ, and then finally results. So there are 10 examples built into RTD. I'll show you how you can import them. And each one of these touches upon a different part of the platform. And you'll notice there's like recorded ground motions, physics-based ground motions that were taken from the NGIOS database. For today's demonstration, there's different hurricane databases that I'll show you in the back end where we could simulate our own hurricane. I'll be doing that today. And then how we can run different types of other types of analysis, such as tsunami, regional site response using the soil column under a structure. And the idea is all these examples come prepackaged in RTD, and you can just go to the menu bar, select examples, pick the ones you want, load it. And you could use that as a starting point for your analysis going forward. So you could pick the one that most similarly resembles the type of research question you want to answer, and then build it out from there, change that inventory, change the hazard, but keep the general kind of workflow. And note that many of these examples are watered down test beds. So you'll see a few thousand buildings here, but we have test beds that are hundreds of thousands, millions of assets that we've run on the supercomputer. So it's quite powerful, the amount of assets you can run. And here I mentioned you can run jobs remotely and locally. So if they're small simulation jobs, you might want to run them on your personal computer, kind of set up the analysis, and then you could take all the buildings and run them on TAC, if you want to save on electricity costs. TAC is a supercomputer out in Texas. This is me. I was at TAC last November, and it's quite an amazing facility, and it's completely free. So you can run all your examples on TAC at the Design Safe servers, and it's a great tool, great option to have. Recently, I've also implemented housing demographics. So say we have assets like buildings or pipelines, and you want to figure out what population demographics those pipelines serve, or who lives in these houses. RTD has built-in functionality to take the census information and automatically augment your asset inventory to include that. So you'll see here there's a % white, % black, % Hispanic of the population that lives in this census kind of area. And then you could use that to establish kind of a baseline for who lives in these houses and figure out who is most affected by different types of natural disasters. Okay, so without further ado, I'm going to provide a demonstration now. So I'm going to open up RTD and kind of walk through it a bit, show you how it looks, how it functions. And I'm going to simulate a hurricane, and then we're going to run a regional damage and loss simulation for a small subset of buildings for that hurricane. So I'm going to turn this off now, and I'm going to bring up RTD. And hopefully you can see it now. So first I'm going to highlight this menu bar. This is kind of where you can access a different QGIS functionality. So you notice here I can zoom in, pan, zoom out. Everything that you have in QGIS is kind of part of this platform here. If I go up here to GIS map in the menu bar, you'll notice that it's the QGIS menu kind of just tucked in here, and it will allow you to access, say, their documentation and their different functionalities that's available in QGIS. And going back to RTD, here's that examples menu as well. So you can download the different examples you want here, and then they'll appear here in this list. And you can load an example, which I'm going to do now. I'm going to load example hurricane wind, which I'm going to use later on in this presentation, but just to give you an idea of how it looks. So this is Lake Charles. And if I zoom in here, you'll notice this raster, which is a hurricane wind field. Speed's going from about 90 to 141 miles an hour. And if I zoom in, you'll see the building inventory. And in this case, there are, let's see how many, 26,500 buildings. So about 27,000, let's say, buildings here. And you'll notice everything's at the parcel level granularity. So it allows you to go analyze building by building. And when you send this off to the supercomputer by clicking on the Run at Design Safe button, I'm just going to log in here quickly. So you give it a job name, you select the buildings you want, you say the number of nodes. You don't want to request too much nodes because then it might wait in queue forever. But you want to give it a few nodes, a number of processors per node, so you can go up to, I think, 60 something, and a number of buildings per task. So what this means is, say you have 64 processors and you have one node, it's going to run 64 parallel tasks, if you will. And in each task, it's going to have 10 buildings, like a small batch of buildings. It's going to analyze one by one until they're all done and then combine the results at the end. So everything is run kind of embarrassingly parallel. So the more nodes you have, you could scale up to run, thousands of structures at once. And then when you're done, you could just click on Get from Design Safe. Your jobs will appear here. You could right click, say Retrieve Data, and it's going to suck it right back into RTD. Now let's go through some of these panes here just to give you a general idea how this looks. Sorry, before I go that, I want to focus on one more menu item here. So there's tools. This is where the tool section is in RTD. This is that census data allocation that I kind of talked about previously, where you can select a layer and then download the different census data to augment that layer with. There's the earthquake scenario simulation, where it allows you to simulate an earthquake. I won't spend too much time there. And then there's the hurricane scenario simulation. So this is the one that we're going to run today. We're going to create a grid, import a hurricane, do all that, and then create a wind field. But I'll get to that in a second. You can also load results that have already been done. You can clear the inputs, and that's about it. And load also examples that you create using file open. So I'm just going to step through here, give you a rough idea of the different types of panes. So here's a general information pane. Like I said, it's very high level, just the name, the units, the different types of assets you want to include, and the granularity of your output settings. So you could output every realization of every EDP, of every damage measure, of every DV, and you get a lot of data. So you want to, if you're running 1 million buildings, you might want to be sparse and just perhaps get the final output. This is where we define the hazard. So you'll see here's a raster defined hazard. When we run a hurricane simulation, it's going to be a user specified hurricane. What that means is we're going to have a grid.
Steve, I think you're frozen.
Sorry, I think I lost everyone. Am I back?
Yes.
Oh, perfect. So sorry about that. Okay. Hopefully you can see the screen again. I'm not sure where I lost you. Was it right here, somewhere around asset definition? Yeah, okay. So here's where we define our asset. Here I'm using a
from like general information, I guess.
Oh, I lost your general information?
Yeah.
Oh, okay. Okay. I'll quickly go through this again and then I'll go for it. So general information is where we give it a name, units, the type of assets, and then the different output settings. So it's essentially the granularity of the output, whether you want every realization of every damage variable, every EDP DM. So for really large analyses, you want to keep this sparse and perhaps just output only the results at the end. here's where we define the hazard in the hazard pane. You'll remember that I said this was a raster or a TIFF image. So this is a hurricane for TIFF. I'll show you how to create that grid, which will be a user specified hurricane. And essentially all that is you define a grid in CSV like Excel, and each grid point you define the wind speeds or different intensity measures. And I'll show how that looks. And then we have our asset definition. I'm using a GIS file, so a geo package to import my Lake Charles building inventory. You can also have a CSV file where each row is a building and each column is an attribute. And this is how it'll look again if it was a CSV file. But here I take a geo package or a GIS file and do convert it into a table. Again, each row here is an asset, and then you'll notice the different types of attributes we have available for these assets. And you might not have all these for your building inventory, but in this case, we have year built, roof slope, mean roof height, and so on and so on. This is the hazard to asset. So how do we link our hazard to our asset? This case is site specified, but there's also nearest neighbor. And what site specified means is if I zoom into my site here, it's going to sample this raster at the centroid of my polygon, or if it's a point, just at the point to get the intensity measure, in this case, the wind speed. And have a grid, which I'll show. And then instead of sampling, you can't sample the grid, you'll just try to find the nearest neighbor or nearest neighbors. So you can sample from 2, 4, 5, however many nearest neighbors you want, and kind of average that out and get the intensity measure. And then we have our modeling. We're not doing any modeling in this case. It's just going to be IM. So we're taking our intensity measure and using that as our engineering demand parameter. And then for our damage and loss, we're using Pelican, which is perhaps you've heard of it before. It's our damage and loss module at the SimCenter. And you'll see there's different types of methodologies. We're using the HAZUS MH Hurricane today. And we're also using this auto-populate script, which takes the attributes from the buildings and assigns it to a particular type of fragility function. So you may or may not use this, but it's pretty powerful if you do. Essentially in this Python script, it's just a rule set where let's say my building is, or my roof style is hip. Well, then I'm going to use this fragility function. If my roof style is flat, then I'm going to use this fragility function. So you just make these rules to tell R2D or to tell Pelican which fragility function you want to use based on this asset. So for each asset, it's going to run the script and then figure out the fragility function going forward. And then UQ and RV, I won't spend too much time there because they aren't quite supported fully yet. And then the results will show up once we. Okay, so I'm going to clear this example 8, and I'm going to open an example I created for today, which is called the GSC example. And it's essentially example 8, but without the hazard. You'll see the hazard failed to read, which means there's no hazard here. I only have my building inventory. So there's nothing here under hazard. So we're going to create the hazard today. I'm going to go to tools now, and I'm going to go to hurricane scenario simulation. And I'll see my GIS screen again, but now I have these other selection items up here, and you'll notice it's kind of a pop-up. I have 2 screens, so sometimes things might pop up on another screen. But I'm going to select the hurricane from a database. So I'm going to go up here to hurricane definition, select from database, and I'm going to load the hurricane database. So now it loaded every hurricane that's occurred in the last 3 years as part of the NOAA IB Tracks kind of database. It's built into RTD. So you could click that, you'll notice some of these hurricanes run across the map. That's why these lines do that. But once I zoom in, they go away. So I'm going to zoom into my building here, and you'll notice that there's a hurricane that runs very close, right through pretty much Lake Charles. And that's Hurricane Laura. So we'll use that one. I'm going to select this hurricane, and I'm going to zoom out, and you'll notice that this is kind of the only one left there. And you'll notice each track point and this kind of blue diamond here that specifies the landfall location. So using that database, R2D will figure out where the first landfall is. You'll have some hurricanes that make landfall twice. So you may want to change your landfall. You might want to clear it here and then define the landfall again somewhere. And perhaps want to do that. But in this case, I'll leave it the same. It's very simple. It'll pull the landfall values from the database that you need. So we got our track, we got our landfall. Now the only thing missing is their grid. So we're going to zoom in here. And I click on Define Grid on Map. And I see this little grid widget thing pops up. So I want my grid to cover my assets, and I want it to be fine enough so that I can, let me see what I want to do here. So I have a decent wind field. They don't all sample from the same point. So I'm going to increase the divisions here to 25 in each direction. And now you'll see there's something's there. And I'm going to click on Select Grid, and the grid is created for me. So when I click on Run Now, at each site, it's going to give me 3 peak wind speeds, so 3 intensity measures. But first we got to run it. So that's what I'm going to do now. And we're just going to leave it at 3. I'm going to leave everything as is. And then I think I click the run button. Yeah, it's running. So it's running now. I'm going to close this. And it says here running script in background. We'll give it a few seconds. And we're done. Okay. I'm going to zoom back into the hurricane grid. And I'm going to identify, and you'll notice the peak wind speed. Now, we do have a bug here that's going to be fixed on the next release. You'll notice that these wind speeds are a lot lower than what was shown in that raster. So again, this is going to be fixed on the next release, but it won't change the workflow. Everything you see here will stay the same. Just these results will be more representative. So as I click on each green point, you'll notice that the wind speeds change. And you could sample many wind speeds. Now we want to use this track in our analysis. So I'm going to show you how this looks. So I'm going to go here to RTD. Everything is done in your kind of work directory, what we say. So your remote work directory is where you'll download and upload things from Design Safe, and local, where I ran now, is where you'll run these little local kind of assessments. And in this temp SimCenter folder is where the actual analyses are run. And in this hazard simulation folder, this is where these different hazard simulations occur. So as I said before, I could simulate a ground motion. And in this case, I simulated a hurricane. So I'm going to click on hurricane. And then on output. And you'll notice I got a whole lot of CSV files. So at each one of these points, a CSV file was created. And if I go down to the bottom, you'll see this is an important file called event grid. I'm going to bring that up to see how it looks. So each one of these is a ground motion, or not ground motion, a station, I should say, station file. And each one has a latitude and longitude. And if I click on one of these files, let's see, 640, you'll notice there's a header at the top. This is peak wind speed, and then each sample or each intensity measure for that station. And you can have more than one intensity measure, like peak inundation height, so on and so on, depending on what type of analysis you're running. And then you can have many samples to kind of introduce some uncertainty into the picture. But now I'm going to take everything here, but let me first bring up this GSC example folder. So this is how the folder looks for this example that I'm running. You notice there's an input JSON file. This is the one created by RTD that's then fed into the backend. This is how it looks. So, you know, this is easier for a computer to read than a human, so I won't spend too much time here. But it's essentially a JSON file that sets up the analysis and how it's going to run in the backend. And in this input data folder, there's an intensity measures or IAMS folder that is now empty. So I'm going to copy this into here. And it might take a second to zoom. There we go. So that's loading that now. And now RTD knows where to look, where to find this grid. So I'm going to close this, and then let's load this new example now. I'm going to clear everything. You don't have to, but just to show how that looks. Open GSC example input.json. So there we go. Now we have a hazard. This is that grid we just created. And we're going to now run how many buildings? Let's see. So I have here a filter of 20 buildings. So I just did the ID from 1 to 20, just to keep life easy. And I'm going to click run now. So now we're running the simulation on 20 buildings locally. This is on my computer. If I was to click on run a design safe, I would fill out those few things, click upload, and that's it. I'd be done. I'd go have a sandwich, have a coffee, come back. I'd check here if my analysis is done, and then bring it back in. But now we're running it locally. And we'll have to wait a few seconds here. You'll notice in the bottom, there's a elapsed timer telling you how much has passed. There's also a progress bar. And now it's cycling through each building, running an analysis, picking the proper fragility function, calculating the loss ratio, I believe. Yeah, so here we have a loss ratio, and the repair cost is almost the exact same thing. It is the exact same thing because we have no value to the building, just a loss. And you'll notice they're very low losses, which makes sense. We only have 60-mile-an-hour winds, so they're almost non-existent. If I go here to loss ratio, you'll notice it's very small. So what I'm going to do now is I'm going to load example 8, which is the same one, but it uses the more proper raster, so the hurricane wind field. And I'm going to run, I believe this is the same buildings. Yes. Okay, so I'm going to run this again. And now it's going to sample at each building. It's going to sample the raster, get the intensity measure, and then send that back to the back end for analysis. And we'll hopefully notice when this is done that we'll have some actual losses that occur. And again, you'll notice the wind speed varies from about 90 to 141 miles an hour. So quite larger than the 60 to 70 we had before. Again, that's a bug that will be fixed. Okay, here we go. Now if I expand this, you'll notice we have a loss ratio up to almost 70% on some of our buildings. It's a lot more varied, a lot more jagged. And let's go back here. Let's turn this off. And let's see here. What do I want to show next? Maybe we'll go back here. No, we'll go back here. Okay, next I want to highlight the different filtering functionality. So you'll notice there's two layers here, or there's one called selected buildings, and then there's our main building layer. So if I click here and I go to show feature count, you'll only notice there's 20. So I don't necessarily analyze all my buildings at once. I need to select the ones I want to analyze. And there's 20 out of how many did we say there was before? About 26,500. And we might not want to analyze the same ones every time. So what we can do is we can go here and apply a filter. So I'm going to turn this off, and I'm going to go right click on the layer, the main building layer for our entire inventory. I'm going to click on filter, and then this query builder will pop up kind of what is standard in QGIS if you used it before. And you notice now all my fields for that particular layer appear here on my left. So let's click on roof shape and then go sample. You'll notice all the roof shapes that appear in my entire inventory will come up here. And I may want to say, let's first analyze all assets that have a gable roof. I'm going to click on roof shape equals gable and click test. And 11,357 rows. So of all my 26,000 buildings, about 11,400 have gable roofs. I click on OK, and you'll notice it looks a lot sparser now, the building inventory. So, but almost half have gable roofs. So now we can add these, select all these buildings, add them to our analysis, click run, or send it off to the HPC, and we'll have a loss distribution of the buildings that have gable roofs. Now I want to come back here, say, no, I don't want gable roofs anymore. I'm going to clear that. I'm going to click on roof shape equals flat, right? And if I go test, you'll notice there's 3,000 buildings with flat roofs. Okay, now I have flat roofs. I could run all my assets with the flat roof, and then compare the two. See what difference roof shape makes in Hurricane Laura, right? How would I fared better if my roof shape was a little different? And we could go to different types of building classes, occupancy classes. If we have, if I included, say, the census information here, we could look at low-income houses, run those, and then compare how they versus high income houses to see the disparity between different types of the population. So it's quite powerful where you can go through the different types of fields, choose the assets you want to run, and then send those forward off into an analysis. And I'm going to clear this filter quickly and showcase kind of another little feature. So let's say I'm concerned about a particular region here as well. So I could zoom in on that and I could click on select. I could highlight certain buildings. I can add certain buildings, you know, the ones that interest me, like maybe hospitals or schools, or I don't know, some particular community that I feel should be analyzed. And then when I click add assets, those assets will be added to the list here. And I can go forward and analyze those. And then I also want to highlight the main difference between this example 8 and RAN, which is just pretty much example 8, but with that hurricane grid, is that, as I mentioned before, example 8 uses a raster, and in this hazard to asset kind of application, you'll notice it says site specified, which means at each site, it will sample the raster and get the IM. And this other one, if I go say file open, so I'm going to open the one with the grid now. And you can make this grid fairly high resolution too. It's up to you. You saw how quick it was for this 25 by 25 grid. You can make it quite, you know, quite fine. And I can go here now and you'll see it's nearest neighbor, which allows me to sample a number of neighbors randomly and take how many samples from those neighbors. So remember before I had a list of intensity measures at each point. If I click here, you'll see there's 3 wind speeds, and it'll just go around your neighbors sampling these different wind speeds to get some, you know, statistical idea of your intensity measure using the nearest neighbor approach. And yeah, all these points are correlated, of course. So you should go to the different neighbors and have similar values. And what else do I want to mention here? Previous semester. Yeah, I think I showed everything for the. Yeah, so any questions? Let's open up to questions now. I'll leave this open, so in case there's any RTD questions, and then we can go back to the slide for more general questions. I'll just have one slide left to show regarding the forum.
I have a question.
Yeah, shoot.
Yeah, so like I was using like the hazards tool of like FEMA. So I mean, can you please like tell me that what is the difference between, I mean, hazards and this RTD tool?
Okay, so that comes into, say, damage and loss. So the difference here is that we use the same or similar, I would say, fragility functions as hazards. So it won't be much difference there, but you'll notice there's something here called user provided fragilities. So let's say I'm a researcher, I want to create my own fragility functions for earthquakes now. And I don't want to use the hazards ones, or perhaps I want to compare to hazards, which I have here, but I have my own fragility function. Say I designed a fragility function for the 3 different roof types. So I have one for hip, gable, flat. I have an auto population script, which it'll find my fragility functions in this folder and automatically be available in the script. And it'll allow me to select my fragility functions now and use that in a regional analysis. So I'm not just stuck with hazards. I can create my own fragility functions or use another researcher's fragility function as well. Like here's an example. If I load example 9 tsunami, this one I believe uses that. Yeah, so I use custom fragilities from NHERI. So from the NIST center there, NHERI, I take their fragility function and I use them here to run a tsunami analysis on this column of buildings.
So like in hazards, in hazards, we used to import the depth grid from the from FEMA website, like for the floods. So like this tool, you did imported the depth grids for the hurricane or other hazards.
Yeah.
So I mean, I can analyze in this for floods also like using the flood grids, depth grid from the FEMA?
Yes. Well, you have to convert it into SimCenter format first. So if you can write a script that takes, say, the FEMA grid, and then if you put it into that same format I showed you, or I showed previously, where you have the event grid file that has each kind of ground point, lat long, and then each ground point is its own CSV file with different columns for however many intensity measures you have, or attributes, whatever. You can use it here. So it doesn't support, say, the FEMA map per se. I don't know what format the FEMA map is in. If it's in GIS format, then we also have this GIS wizard where you can.
Yeah, it has like .tiff like files.
Oh,
as
yes.
templates.
So if it's a raster, then you can
Yeah,
use
raster.
that.
Yeah, it is a raster file. Okay.
So we have a raster defined. So in this case, the tsunami is a TIFF, right? I have my
Okay.
inundation depth as a TIFF file.
Okay. Yeah, got it. Thanks.
So I see that Richard has his hand up, and then we also have a couple of questions in the chat.
Yeah, I have I guess a few questions. In the list at the beginning, at the very end, you had a recovery. Is that built into this as well?
Yeah, so you might be familiar with RTD at Europe. So I'm working to bring RTD open source. I'm creating an open source package, and I'm going to be implementing it into the RTD, like the recovery module. And then we have 2 or 3 other recovery modules that are currently being implemented. They're not done yet, but recovery is in progress, put it that way.
I see.
But it's coming down the pipeline.
And the other thing you mentioned is, we didn't do it here, but you said you can do modeling as well.
Yes.
What kind of modeling does this accept?
Yeah, so let me go to example 4. This is where I used to live, in the University Village here at UC Berkeley. If I go to modeling now, you'll notice there's an OpenSea's Pi script generator. And I create essentially a Python script. This just creates a cantilever. And all the information in this asset definition table is available to every I should say method or model downstream. So if I have something here that describes my building inventory, like occupancy class, structural type, I'm going to have it available downstream. And I just use that in the script called cantilever light. I say if my building is 3 stories high, I create a little OpenSea's Pi finite element model. If it's concrete, I use this material. If it's steel, I use that material. So there's different ways for you on the fly to create these finite element models for pretty much an entire region, depending on some basic building attributes.
So is this only limited to buildings then?
Currently only buildings, but you know what, I've never tried it on other types of infrastructure, but I don't see why it wouldn't work. Like, what types of infrastructure are you
Well,
interested
I'm
in?
thinking of transmission and distribution systems for electrical components,
For
so like power
electrical?
poles and power lines.
Yeah, I don't see why you couldn't. You just create your own script that has the it will have those attributes, or those columns and the asset definition available, and then you could create your own OpenSea's Pi model. So currently we support OpenSea's and OpenSea's Pi. I'm not sure if there's other types of analysis.
Yeah. And so if you do, I don't know, for example, you do that electrical grid model, you can make your own fragility curves, implement them here. Can you also change or implement your own intensity measurements with those fragility curves, or how does it work in this? Yeah,
so your intensity measures are supplied through your hazard definition, right? Your intensity measure field. And that is available downstream. So say I get to my analysis stage, I have my intensity measure, obviously. I have my model that comes from the model stage, and now I could combine the two. And I'm not sure what you mean by, perhaps you want to augment your intensity measure based on some model parameters. Is that what you're saying? So yeah, you can do it. You can do it at this step here. It'll just have to be some custom.
Oh, I see.
Up to you to make that. We haven't gotten that far yet for other types of infrastructure. For buildings right now, it's kind of seamless because OpenSea's Pi, OpenSea's
And I guess
the standard for that.
the last big question is, what other hazards will be implemented into this?
So currently we have, what did I say? We got earthquake, tsunami, hurricane, and flood. I think is the last one that we're looking at
Okay.
to implement in the near future. But what other hazards would you be interested in, like temperature, or what would be?
I think a lot of people are now focusing on wildfires. So
Wildfires, yeah.
that's one.
So at RFPA, we deal with wildfires, but it hasn't come up yet at the SimCenter. Like it's been in discussion, but I don't think we
Thank you.
have it on our.
So we have a few questions in the chat. Shen asks if you have the building inventory for the entire United States.
So we don't, but others have it. And if it's in GIS format or CSV format, we can bring it in. So we are working. I'm the wrong person to answer this question. I know we have been working on, because there's the building inventory working group, which I'm not part of, but we are working on that, getting some sort of building inventory database, but that's not really in our purview. It's just we're kind of combining the different databases out there that are available, and hopefully, we can guide you to the right one. But if you have a building inventory out there that's typically in GIS format or any type of GIS format, you can upload it and use it quite easily.
I mean,
But-
GIS format, like you mean by like geo package files, like that can be also.
Geo package, shape, GeoJSON, ESRI, like any type of GIS is
Because
supported.
because NSI inventory is in like they have the like geo packages and GeoJSONs.
That's fine. Yeah, anything that QGIS uses, which is almost anything in the GIS
Okay.
world,
Okay.
RTD can load and use and parse.
Okay.
We have another question in the chat asking what methodology you're using to estimate wind speeds, such as height above ground or terrain. Are you using HAZUS methods for estimating surface roughness?
So that's a great question. And again, I don't think I'm 100% qualified to answer that one because I didn't implement this hurricane scenario simulation, and there's no citation here, which there usually is. But I do know we have, so if I go here to specify hurricane track, there's a terrain roughness GeoJSON. It just uses I think open terrain now to be conservative. This is based on, God, I wish I remembered this. I'll get back to you on that question for sure. I can, if you want to shoot me an email, I can get back to you. But I believe
that was me. That would be, I can shoot you an email because I am really curious to be able to compare my models with what y'all have just to do some estimating.
Benchmarking, yeah, for sure. That'd be great. Because Quanchi Zhang, he developed the wind field simulation.
Okay. Yeah.
Methodology.
Thank you.
So.
And then we have another question asking if it's possible to predict loss of assets or property under certain levels of hazards or in certain damage states. This person is interested in potentially adding a policy context where this type of software could be useful when presented to FEMA or other emergency managers.
Okay, can you repeat the first part of the question? I missed.
Yes, they ask if it's possible to predict the loss of assets or property under certain levels of hazard or in certain damage states.
I'm not sure I understand it 100%. So under certain levels of.
Rahendra, do you want to speak up and maybe clarify your question?
Yeah, I would like to ask you questions. May we predict the losses of property or assets in a certain level of risks? I mean hazards level. We can then we may validate those losses for the future mitigation measures.
Yeah. So what you can do is you could scale your hazard. Nothing's stopping you there. Like you can go into, say, the hazard definition, and let's take this one I have now, for example. This isn't a good one. Let me load. let's do this one, basic hazards. So this is just a quick earthquake example of San Francisco. And the grid will pop up in a second, but there's nothing stopping you from creating different levels of hazard. Let's say a low intensity earthquake and a high intensity earthquake. And then you subject it to different types of assets, and then you can compare those results at the end. So one useful feature here is you can select, let's say I run this analysis, I click run, and hopefully it'll be done in time. A layer pops up with the loss ratios, everything here. I can right click that, I can go to export, save features as, and then I could save that as a shapefile or any type of, this huge selection here, let's say GeoPackage, and I can have 4 or 5, let's say, results, and then combine them in another GIS platform like QGIS to see those differences like you were talking about, and perhaps how they impact low income, let's say, residents. And then you could forward that on to policymakers, but it would require some post-processing like I described. So you can run an analysis, save your results, and then post-process it down the line. So hopefully I answered your question. If not, we can talk offline.
Okay, sure.
Rakesh, you've had your hand up very patiently for some time now, if you want to ask your question.
Yeah, I guess this was already discussed when Stephen answered a prior question, but I was going to ask about whether R2D tool supports analysis by other assets like infrastructure assets like bridges, retaining structures, or dams, and things like that. If not, is there any plan to provide support for such assets in the future?
Yes, another great question. As was mentioned at the very start, I worked on this other program called OpenSRA, which is specifically designed for natural gas pipelines. And that's being launched at the end of March, kind of officially going open source. And that's essentially R2D that's been modified to work just on natural gas pipelines to make it easy. It's sponsored by the California Energy Commission, and it's intended for natural gas company, like energy companies in California, to use that to do the risk assessment on their inventory. So that's coming into RTD. We have water pipelines that are done, but not polished enough, I'd say, yet for release. So very soon we're going to have water networks, natural gas networks. We have building, and then there are plans to bring in electric transmission systems, and then transportation is kind of the last thing on our list. But for dams and stuff, not yet. I don't think there's been a demand that big for dams. But yeah, we're open to collaboration. Everything's open source. It's there if you want to implement your own dam assets and fragility functions and create your own example using dams. That'd be great. And we'd help you. I'd be happy to help you along the way.
Great, thank you.
Steve, you have a lot of questions here. This is fantastic. There's a few more in the chat, if you don't mind. These will probably be the last ones that we'll be able to get to this session. So the first question is asking if there are any vulnerabilities to the data regarding demographics or loss predictions.
So by vulnerabilities, what does that mean? So, sorry, I don't understand.
Jasmine, do you want to clarify what you mean by your question?
Hi, yes. So I just mean from like a privacy and security perspective, the data that is collected like regionally, is there any type of vulnerability to the exposure of that data?
So it's completely data that's available as census. So I query the government API. So it's public. It doesn't go from household to household and say this person makes this much, this person lives here. It's on a census block level, I believe. So okay, it's anonymous data. But what we do is we take that anonymous data, like the statistics, and then you can create a profile, let's say a household profile, saying in this house, we estimate that 20% of people are Hispanic. And then you roll the dice, and for each house, you kind of assign a family, if you will, or a population.
Great, thank you for that.
Yes. So there's no personally identifying information.
Yes, thank you.
This may be the last question that we can get to. Vincent, I want to encourage you to maybe email Steve your question following this session. So Javed asks if it's possible to analyze impacts from multiple hazards at the same time, for example, examining compound hazards.
Yeah, that's a great question. So we're working on that, but not currently. Like in the tsunami example, you not only have damage from the earthquake on the building, but then the tsunami comes right after that and impacts those damaged buildings. So that's not compound hazards aren't implemented yet, but it's in the works. It's very complex problem. And also also for earthquakes as well. We've tried to run workflows where you have one earthquake and then use it as damaged buildings kind of in the second, say, aftershock. But it's not released yet in an easy to use kind of package, I would say. Compound hazards.
Thank you so much for answering all of these questions, Steve. I'm going to go ahead and I'm going to share my screen just to wrap us up, if that's okay.
Just give me one more second. I just want to show
absolutely.
the final slide. So we have a forum here. If you have any questions that I didn't answer today, or you think of another one, feel free to go to the forum here, the regional hazard simulation, or I believe that's one for RTD. And yeah, ask a question and we'll get answered by someone. So thank you. I stop sharing now.
Thank you. So I want to thank everybody for attending today's workshop. This was an incredibly interactive one, and we are so thankful for our speaker, Steve, as well as all of the participants who attended today. I'd like to invite all of you to join us next month at the next and final workshop, part 5 of the workshop series, where we'll be discussing data integration using relational databases and application programming interfaces with Scott Brandenburg from UCLA. So that will be at the same time, second Friday of the month, March 10th at 11 a.m. Central Time. I just wanted to thank our speaker, Stephen Gavrilovic from Berkeley and SimCenter, as well as all of the fabulous organizers without whom this workshop series would never have been possible. Though he's not named here, I also really want to thank Adam from SimCenter, who connected us with all of the fabulous facilitators that we've had at these workshops. Finally, for those of you who may not be members or maybe members but not quite sure how to get involved, I'd like to invite you all to join the NHERI GSC, and if you are already a member, to join a working group or several if you'd like to get involved. This was a joint effort, as I mentioned, between the research working group and the workshop and mentor. Am I getting the right workshop and mentoring working group? But there are other fabulous working groups that are working on some initiatives this year. Finally, I would like to invite everybody to join and submit an abstract to the NHERI GSC mini conference. These applications are due by February 24th, 2023. The QR code to submit an abstract, which is limited to 500 words, is at this link or at this QR code. And I'm happy to linger for a couple minutes if there are pertinent questions that I can answer. And with that, I would just really like to thank all of you for joining us today, our speaker, Stephen, and hope to see you all at the next workshop on March 10th.